everyone. I wanted to go over 2C. We didn't have time to get to it in class, and that was one of the problems that people had asked to review. So this video is just going to go over that one problem. So this is homework number 6, problem 2C. And I'm going to share my whiteboard with you right now. So this particular problem is a strict conditional, and we've got these fish-hook claims right here and here and here that we need to translate into box conditional claims. We are also trying to figure out whether this is valid or invalid in N, which is a non-normal logic. In this particular section of the book, we're told that this is valid, so we need to show that it holds in N. So first order of business is to translate this and to translate all the fishhook claims so that we have just boxes and conditionals. So because this is a giant fishhook claim, it means that we've got a necessity claim out in front. And then inside the necessity claim, we've got this conjunction made of two conditionals. So it's A, then B, and box B, then C. That's that first part of the conditional. Then we need the second part, which is going to be box A, then C. And all of that we are going to assume is not the case at world 0, and that's how we're going to start our tableau. This is a negated box conditional claim. So if you look out here, we've got the negated box. We need to change that, but inside the main connective is this conditional right here. So let's take that negated box claim and use the negated box rule to get diamond, not box A, then B, and box B, then C, and all of that. If all of that, then you get box C. Box A, then C. I'm going to put you down for just a second. A little bit easier. Okay, we are working in N, which means that we can use a diamond rule at normal worlds. Normal worlds are world 0 and any world where a box claim is true. Since we are at world 0, we get to assume that 0 is a normal world, so we do get to employ the the diamond rule. So we get that 0 is related to 1. It's not the case that box A, then B, and box B, then C, and if that, then box A, then C, and all of that is true at 1. Then because this is a negated conditional claim, we get to apply the negated conditional rule, and that means that we get box A, then B, and box B, then C, and all of that is for world 0. And we get the negation of the consequent, which is negated box A, then C at 1. And that is me just taking the negated conditional claim to this right here. I am going to take this claim because it's a conjunction, and I will use the conjunction rule, which allows us to say that box A, then B is true at 1, and that box B, then C is true at 1, and that is me taking the conjunction rule to this claim right here. From there, we can take this claim and we can use the negated box rule. So we get diamond, negation, A, then C at 1. Now, we can only use the diamond rule. Sorry, that was supposed to be blue. We can only use the diamond rule when we're at a normal world. And because we're in N, we can assume that all worlds are non-normal unless it's world 0 or there is a necessity claim true at that world. Well, there is a necessity claim true at world 1. In fact, there's 2. So that means that 1 is normal, not non-normal. So that means that we can apply a possibility rule. So we can introduce a world, 1 can see 2, and it's not the case that A then C is true at world 2. Once we've got that, you can then apply the negated conditional rule. So we get A at 2 and not C at 2. All I'm doing there is taking this one and applying it. I've done that. All right, from there, we can then look at these claims right here, which are box claims. And since we know that 1 is related to 2, we know those claims within the scope of the box are true at 2. So we get A, then B is true at 2, and B, then C is also true at 2. And that's because I've done this one and this one. Sorry, I haven't marked this one, even though I did it a little bit ago. From here, you can split your conditionals. So if I have if A then B at 2, I've got not A at 2 and B at 2. And that is me taking this claim and applying the conditional rule. Well, we've got a contradiction here because not A at 2 and A at 2 contradict. Now we have this one right here, which I can then finish by splitting that, and I get not B at 2 and C at 2. And I get a contradiction here, this one and this one. And then I get a contradiction here, this one and this one. And that is it. That's our proof. You want to zoom out and see what we've done. This is 2B. We are told that it is valid in N and that we need to prove it. We have applied all the rules that we can. All of our branches have closed. So this particular argument is valid. And there we go. Okay, that's it. If you guys have any questions, please let me know, but this is 2B.